Welcome to Smarter Circuits. I'm your host, Ian Klein. I have a fairly long list of videos that I've been planning for quite some time, and I even have some videos shot for some of them. But there is one topic that I've realized would help more of my viewers right away than the rest: using a momentary switch to control a Shelly relay, or similar device. If you're not using an old low-voltage system, you may wonder why this is so important, so I'll explain. In a legacy low-voltage system, the wires that run throughout the house to the switch plates are not rated for 120 volts, and most relay modules on the market require you to use the same hot wire that supplies power to the device as the switch input. There are other ways the application I'm about to show you can be used, so even if you're not dealing with a legacy low-voltage system, this information could come in handy, so stick around. The Shelly relay module I'm using for this example is the Pro 4PM I covered a couple videos ago, but this technique can apply to many different devices. The concept I'm about to describe is a simple one, but many people overlook it because it seems redundant or overcomplicated. But there are a few really great reasons to do what I'm about to show you. The most significant reason is the much lower cost for wire and the safety of using lower voltages and currents on your longer wire runs. Here we have our relay module, which can be configured to use a standard latching switch or a momentary one. But as I mentioned before, the drawback is that you need to use the same hot wire to power the device as to control the switch input. If you're using heavy gauge wire and a standard light switch to perform this function, you don't need to worry about this. But what if you want to use a smaller switch or smaller wire? What you'll want to do is add another relay that you can control with a separate power supply. This gives you a lot of flexibility and can also be used in situations where you want to pick up a switch or button state on a long wire run with something like a Raspberry Pi. Remember this. This is the tangled mess of control wires for my house that comes from all the switch plates. Even with this pull-down resistor circuit I built, the problem is that with such long wire runs, any electromagnetic disturbance around the wire may trigger false button pushes, as the GPIO port on many devices like the Raspberry Pi is quite sensitive. This setup worked great until there was a thunderstorm that sent my house into poltergeist mode when I had the Raspberry Pi hooked up as my smart controller. This Shelly relay is configured to use a momentary switch. The relay next to it serves as the 120-volt switch, and the leads coming from it would be the wires coming from whatever switch I'm using. In this demonstration, I'm keeping it all together for visual purposes, but if you're converting an old low-voltage system, you'd simply install your power supply in place of your current transformer, which is just a different power supply, and probably looks like this. Make sure you know where your wires are all going and test for shorts before connecting your power supply, or you'll have a bad day. You may also want to make sure all your switches are in a good usable state and replace any that are worn out or stuck. As you can see, all I've done here is wired the switch on the hot from the power supply to the little helper relay and used the output from that relay to control the switch input on the Shelly module. Now I can run wires of nearly any length to my switch. I've chosen a fairly beefy power supply here, as the long wire runs will have higher resistance and require a little more oomph to get the job done. And since I'm only really expecting one or two switches to be engaged at a time, worst case, this will also be more than sufficient to get the job done. If you're not sure about how to wire this, I would definitely recommend getting an expert to help you. This video is meant to be an answer to the question, how do I use a low voltage switch to control my 120-volt relay module? There are many other reasons you may want to do this, including using these little switches to detect a closet door opening and engage a relay to turn on your closet light, something you don't really need the Shelly module for, just another relay that can handle the power to the fixture. My little helper relay here would happily do this, unless you wanted to log when the door is opened or closed for some reason. I don't bother with tying my closet lights into my smart system because this arrangement is smart enough for this purpose. So there it is, a way to use a low-voltage circuit to control a larger one, much like the original systems that use these. You can arrange these relays in so many different ways, the possibilities are limitless. I'll try to cover some more clever uses for this setup in future videos, but I hope this gives you some ideas for how to make your own system smarter for less money. Although we don't use our switches at all in this house, it's a nice redundant backup control schema in case something goes wrong with the motion sensors or other control devices. I will be converting all of my control wires to use this configuration this spring, and I'll do another video showing what that looks like when it is done. I have to open my garage door to provide light while I'm working since I have to disconnect the power and it's pretty cold right now. I do hope you enjoyed the video, and of course if you did enjoy it and haven't already done so, please do subscribe to the channel. If you want to know what's going on between episodes, you can follow Smarter Circuits on Twitter @CircuitsSmarter, and if you'd like to help make more and better videos possible, consider becoming a patron on our Patreon page linked below. Thanks for listening to me ramble, and I do hope you'll join me for future videos as I continue exploring smarter circuits.